So in today's session, we'll see how we are using Biot-Savart's law to find the magnetic field intensity on the axis of a circular loop, as well as what happens if the current is passing through a rectangular loop and we need to find out the magnetic field intensity. So for both these calculations, these are actually applications of Biot-Savart's law. Just like we have seen for a filamentary conductor of finite as well as infinite length, we are using the same procedure here. First of all, we'll take a small element. Okay, let's see. So we need to find the magnetic field on the axis of a circular loop carrying current. So we consider the X, Y, Z plane, and then we took a circular loop there. It is carrying a current I. Then we can see that then we took a small radius R, a point here we took, and another point P on the axis, that is on the Z axis. Another point we took on the Z axis, and then we are going to find the magnetic field intensity at the point P due to this circular conductor lying on the XY plane. And radius, and R is the radius of the circular conductor, and AR12 is the distance from the point P to the surface of the circular conductor. That is given by unit vector. That is the unit vector AR12. R12 is the position vector and AR12 is the unit vector, corresponding unit vector. So just like we have done before, like every time we are doing like this only, we'll consider a small length DL. So you know that this is the case of a cylindrical conductor, right? So for a cylindrical conductor, in the first module, we have studied what is the differential length. How we will calculate the differential length? I mean, I'm writing the basic equation. So then according to this figure, we will change whether dr is there or d phi is there. We'll change according to that. Now, the condition, the basic length dl along all the three axes will be r, because we have studied it as rho or r. We can radius, you can give whatever name you want. Now I'm using r or rho, whatever. That time itself I have told you. It depends based on the figure. So dl is equal to dr ar plus r d phi a phi plus dz az. So that is the differential length that we considered on the circular loop. Now, according to Biot-Savart's law, we know that dH, that is a differential, that is a small magnetic field, is equal to IDL by 4 pi into R1 square. That is the distance. That is ideal cos alpha. Ideal cos alpha is what we are, ideal sine alpha. Ideal sine alpha is what we are writing as ideal cross unit vector. So this equation is already familiar for you. So dH is equal to ideal cross AR2, because in the last derivation we skipped the unit vector term and we wrote it directly. That's why we got R cube here, because AR12 will be unit vector AR12 will be vector R12 divided by mod of R12, right? So in that previous derivation we did it directly. So now I thought I will give you all the steps, because at least some of you will be there who will find it difficult. So in this one, here I will give you all the steps. So AR12 by 4 pi R1 square. If you are writing in terms of position vector and magnitude, then it will be cube here. That's it. Yeah. Now we have DH, we have DL. So what we need is IDL, right? So what will be IDL? IDL is equal to, in this figure, if you are seeing, you can understand that radius R. So since the circular loop, radius R will be a constant. As well as Z is also, we are taking a particular point P here, right? So Z is also a constant only. So here only the phi term is varying, right? Only the phi angle is varying here. So then IDL will be equal to I into R d phi a phi. The other terms, they can be neglected. Dr, AR and dz, az can be neglected according to this setup. So I dot dl will be I into r d phi into a phi. So other dot products will become 0. So IDL we got, and now we'll just write the unit vector. So we need to find out what is R12. So R12 is this distance. That is 1 is here, 2 is here. So we need to find out what is R12. So I'll write it here itself, so that you can see the figure also. So R12 is equal to, actually another figure is required. So I'll just draw here. So you have X, Y, Z you have. So this same setup we will recreate here. So this is the point here, point 1 here, and this is the point 2. So this is 1, this is 2. So you know that. So from 0 to 1 it was R, then from here to here it will be minus R AR. So minus R AR, and this is Z itself, and this will be R12. So this is what we need to find out. So minus R AR plus Z AZ, right? And this is R12 that we need to. So that is how. So then according to this triangular law, we can write R12 is equal to minus R AR plus Z AZ. How minus R came? Because in our initial condition, R was from 0 to 1. Now we are considering from 1 to 0. That's why we took minus R. So minus R AR plus Z AZ. So here we will take DL first, and then we will do the cross product, and then we will do the multiplication. So either way you can do. So to avoid confusion only, I'll just take out the IDL from there. So now what we need to do, we need to do DL cross AR12. So we have DL with us, R12 with us. R12 is there, so we can take AR12, right? So AR12 will be unit vector AR12 will be minus RAR plus Z into AZ by mod of R square plus Z square, and similarly DL is equal to R into D phi into A phi. Then what we need to do? We need to do DL cross AR12, right? DL cross AR12. So this one I will just show AR, A phi, AZ, and then first vector DL. If you are taking DL means only phi coordinate is there. So R D phi only is there. This is 0, this is 0. Then if you are taking AR12 means you have minus R by root of R square plus Z square. Then phi term is not there. Then you have Z by root of R square plus Z square. Then you should take the cross product. You will come like this cross product. So that step I will write. I hope everybody know how to take the cross product. So it will be Z into R D phi into AR. This same thing only we are doing in the last session also, but last session I skipped one step. So maybe if you are confused means we can solve it here. So R square plus Z square. For both the terms, the denominator will be root of R square plus Z square, so that we can take it as common and we can add. So now we have DL cross R12, right? Now what is DH? I'll go to the next slide. So what is DH? DH will be equal to I into, that is I DL cross AR12. So DL cross AR12, we write it there itself. So even if you take IDL means I will be multiplied there. That's it. That's all. So don't confuse in that. You can multiply at any time. That is I is the current passing through the loop. And 4 pi into, so we have 4 pi, right? Now we have R12 the whole square. That is, what is R12? R12 is root of R square plus Z square. So root of R square plus Z square, the whole square will be R square plus Z square itself into, we have the one for the, one more R for Z square is there. That is R square plus Z square the whole raised to 1 by 2. Cross product R square plus root of R square plus Z square is this modulus square double square then it will be I into Z into R d phi into AR plus R square d phi AZ divided by 4 pi into r square plus z square, the whole raised to 3 by 2. One thing I want to ask. What is the next step? If we get dh, the next step will be integration of dh, right? So you are getting dh, then h will be equal to integral dh. So that is equal to integral, you know, the value of phi is ranging from 0 to 2 pi. These things we are studied in the basic first module. Then I we can take common, then z into r into ar plus r square into, because integral d phi we are doing, integral d phi, r square into az, and this d phi will take common, divided by 4 pi into r square plus z square, the whole raised to 3 by 2. Now we will integrate and give the limits. That is, h is equal to I by 4 pi integral phi is equal to 0 to 2 pi z into r into d phi. We are just splitting the denominator. R square plus z square, the whole raised to 3 by 2 into ar plus integral phi is equal to 0 to 2 pi r square az into d phi into r square plus z square, the whole raised to 3 by 2. Now when we are doing this, what actually comes is your first term. This first term happens to be 0. Okay, university exam you can just remember and give it as 0. I'll derive. Actually, now I will show you why it is 0. Because you should understand how it is coming 0. Because in Cartesian coordinate, AR is written as cos phi AX plus sin phi AY. That is the Cartesian representation. We can first term red line underlined term. So it will be, we can call it as A. So that will be equal to phi equal to integral 0 to 2 pi z into r into cos phi into d phi. Rather, z r d phi we have taken dot product with AR. AR is cos phi AX plus sin phi AY by root of r square plus z square all raised to 3 by 2. From a university examination point of view, this step is not. But those who want can write, no problem. So whatever you are writing, you should write it very legible and neatly, one side. The one who is correcting the paper, he may not see what, he may not understand that you know the things. So you should make him understand that you know everything. Okay, so that is the main purpose. Okay, well, we can write. This can be simplified as integral 0 to 2 pi. We can simplify it as phi is equal to 0 to 2 pi cos phi d phi. So this will be integral cos phi will come out to be sin phi. So sin phi integral 0 to 2 pi, and this will be 0. Same way the second term also. So now this term we got it as 0. Same way the second term also will be. I hope you are understanding, because when we are cos phi are you having doubt? We are taking the integration with respect to phi. Z r root of r square. All these terms are constant. So all these terms are constant. So that constant will take outside, and that constant multiplied with the 0. So obviously, eventually it is, that is 1 into integral of sine. Integral of 0 to 2 pi, because from here directly actually you can write if you know mathematics, because sine curve, if you are taking from 0 to 2 pi, the average value will be 0 only, because positive half cycle and negative half cycle will cancel out 0 to 2 pi. So average will be 0. So directly you can write here 0. Okay, those who are very keen about these things, you can even write. So for a sinusoidal or cosine waveform, sine waveform anengilum cosine waveform anengilum same effect ആണ്. The total area, integration and the area under the curve. Area under the curve from 0 to 2 pi will be 0 only. So that's how this is completely becoming 0. Clear? So same way, this happens to be integral 0 to 2 pi sine phi. Sine phi d phi is equal to 0, because ZR by R square plus Z square, the whole raised to 3 by 2 is a constant. So what we will get? So that we will keep a constant here, k. So that constant is what? K is equal to ZR divided by root of R square plus Z square, the whole raised to 3 by 2. So that k into 0. So eventually this is 0. So I hope everybody understood how that is becoming 0. Okay, so this first term is now becoming 0, right? You understood that this term is becoming 0. So now what is left? Now what is remaining is, now we can write H is equal to I into 1 by 4 pi integral phi is equal to 0 to 2 pi R square into d phi divided by R square plus Z square, the whole raised to 3 by 2 into AZ. That is the second term. The first term, we realize that it is 0. Okay, so now we just need to apply the limits, do the integration and apply the limits. So in order to apply the limits, you should take it like R square, you can take common. So R square into I divided by 4 pi into R square plus Z square, again will be common, integral 0 to 2 pi, and then it will be d phi. So this complete thing, just like we have taken in the previous derivation where we got 0, this entire thing you call it as k, because you can take it as k. That is k into integral 0 to 2 pi d phi. That will be k into phi, upper limit minus lower limit will be 2 pi minus 0. So that is equal to k into 2 pi. So k in terms of R square into I by 4 pi into R square. Then implies the magnetic field intensity H will be equal to I into R square divided by 2 into R square plus Z square, the whole rate to 3 by 2 into AZ. It is along the Z axis only. First figure it is along the Z axis. Axis Z axis circular ring. So it is along AZ only. Updation axis at a distance of Z. If P is at the center itself, P point Z distance central Z will be equal to 0. We can take H is equal to I into R square by 2 into R square, the whole raised to 3 by 2 into AZ is equal to I by 2R into AZ ampere per meter. So I by 2R into A is at ampere per meter. So this is actually, so this completes the derivation for a circular ring. That is magnetic field intensity due to the current flowing through a circular ring. So I thought of finishing a rectangular ring also, but we don't have that much time. It will take some more time. But I think I can go ahead with that also. Okay, let's see. So this one, I want you to understand this thing, this derivation first. So is it clear for you? The same thing, I will just explain once more. Listen carefully, those who are missed in between. So you have the circular ring. We take a point at a distance P. Now from here we realize that the differential length is changing along R d phi only. And because radius is a constant here, and Z, the value of Z is also constant because the point P is fixed. Then the differential element dl will be r d phi a phi only. Then we can write dh is equal to, that is the Biot-Savart's law. Then unit vector r12 will be vector r12. So this should be vector r12 by r12. So vector r12, how you will calculate? From this figure, because from O to 1 it is plus r, then from 1 to O it will be minus r Z A Z. So minus r Z A Z will give you the third line, that is r12. So r12 is equal to minus r A Z plus Z A Z. That is a triangular law. Then you're taking the cross product, dl cross A. So A cross B, how you are calculating, even in mathematics also you might have learned how to calculate A cross B. So dl cross AR12 is AR A phi A Z, and you got it like dl cross AR is this much value, that is Z R d phi AR plus R square d phi. So just take the cross product and then you apply that to Biot-Savart's law equation. So I think all these steps might be clear for you. I have explained in the video itself. Like I have previously also I have one step by step. So initially you get R square plus Z square the whole raised to 3 by 2. Then we can realize that the first term happens to be 0. How it is becoming 0? Because AR we can substitute as cos phi AX plus sin phi A phi. Okay, so this is A phi. So from that you understood that, oh, no, this is not A phi, no? This is A Z. So from that you realize that this term happens to be 0 because integral sine and integral cos is coming. So that happens to be 0, and then only the second term was required. So we went ahead with the second term, and we finally arrived at the equation H is equal to I into R square into R square by 2R square into unit vector AZ. And if the Z was at the center, means point was at the center, means Z value will be equal to 0. Then you get H is equal to I by 2R AZ ampere per meter. Is it clear? So in this question it is given, find the magnetic flux density at the center O. Oh yeah, this is the center, I haven't marked it. So magnetic field intensity at the center O of a square of side equal to 5 meters. So each side is equal to 5 meters. So you know all the sides will be 5 meters because it's a square, and carrying 10 ampere of current. So each side 5 meters and carrying 10 ampere of current. So you need to find the magnetic flux density at the center O. So same procedure, you need to find it by using Biot-Savart's law. Now let's see how to find it by using Biot-Savart's law. So from this figure you can see that the square surface is lying on the XY plane. So that's what this means. This is lying on the XY plane, and we need to find it on the at the origin. At here itself we need to find, not a point P here and all, not like that. That means here the value of Z is equal to 0. So the value of Z will be equal to 0 because the square surface is lying on the XY plane, and we need to find the electric field intensity at O itself. Similar to how we find out if the circular ring was on circular ring, if Z was equal to 0, finally in the circular ring derivation, finally we took like Z equal to 0, no? So that same case we are finding at the origin. So that is Z is equal to 0. Then what is the next step? We should find out what is DL. So similarly, in every derivation, we'll take a small length dx. Why we are calling it dx? Because this is along the x-axis. This is the x-axis. So the small length dl is lying along the x-axis. Z is obviously 0 and it is not changing along y. So obviously it will be dl will be equal to dx into ax. So a small length along the x-axis. So it is dx into ax. Now according to Biot-Savart's law, you know that the magnetic field intensity is equal to IDL cross AR12 So that is a unit vector divided by, because it was ideal cross sine alpha. So all these things we already seen. And 4 pi into R1 to the whole square. So I think in your 12th physics, you might have studied ideal sine theta by alpha, like the scalar form you might have studied, I think. I'm not exactly remembering from my 12th standard. I think in your 12th standard, you are studying only the scalar form. The vector representation, I think you're not studying. So when you come to engineering, you should know the Biot-Savart law and its vector representation. So whatever you are writing, it should have the direction. The unit vector, the vector divided by the magnitude will give you the unit vector. So that should be mentioned everywhere. So that's how this derivation comes like, the equation comes like dH is equal to IDL cross AR12 divided by 4 pi into R12 square. So I think all these things should be clear for you, because already we have done 2 derivations. So this is third one we are doing with, third application we are doing for Biot-Savart's law. So now what is the next step? Now we should know what is this AR12. That is unit vector AR12. So what is this R12? This is one point, that is from the point, that is the distance from the point where we are calculating, where we are calculating the magnetic field intensity to the point where we have taken the small line. Actually, this should be here. Actually, I have marked it outside. So this should be DL. So R12 is the distance from the point where we are calculating the magnetic field intensity to the point where we to the point where we have taken the current carrying length dx. Okay, so what will be AR12? AR12 will be, so AR12, just like we have calculated in case of the circular loop, here also we should find the coordinates of AR12. How we will find out? So we will take this triangle here, this same one, this same triangle we take here. So this will be O, and we need to find it out by using the triangular law, right? So this direction it goes, then like here and like this it will be. So this is R12. So you know that x is lying in the downward direction, then this will be upward, so that is minus x ax. Similarly, y is from left to right. So, but here we are going from right to left. That means this should also be minus y ay. So AR12 is minus x ax minus y ay divided by root of x square plus y square. That is what actually it was, vector R12 divided by mod of R12. Okay, now tell me if you have any doubts till now. So now we have DL with us as well as the unit vector. So now the next step is to find out what is the cross product, because that's what is demanded by Biot-Savart's law. So AR12 camp. So same procedure, Biot-Savart's law. So those who still don't know how to take the cross product, listen carefully. AX, AY, AZ, and then now you should check the coefficients. So you have 2 vectors, right? DL you have, and then AR12 you have, and both are in terms of, so DL is DX AX and AR12 is you just calculated, right? From the previous slide you can take, I'm not writing it again. So how it will come, DL will be, so first vector is DL, so it will be dx here, and other 2 points will be 0 because only dx is having the coefficient. And then similarly for AR12 you have x and y coordinates, right? There z will be equal to 0, so it will be minus x divided by. So you can see that in all the 3 derivations, the first one, second one, third one, all the steps are same. So those who have missed the any part in the first 2 derivations can still find out the same thing here. Okay, but the coefficients will be different based on the coordinates, because when we consider circular loop, it was cylindrical coordinates. So we went in terms of dr, r, d phi and dz like that. But here it is in terms of x, y, z coordinates. So that difference will be there and you should realize that. Okay, so you got DL cross AR12. Now you take the cross product and what you get will be minus y into dx divided by root of x square plus y square into az. So just take the cross product because only x is remaining. So this 2 will multiply and other terms will go from here. Like same, just take the cross products. Simple cross product that you have studied in mathematics and in the first module itself. Okay, now we have dl cross ar12. Now you apply that to Biot-Savart's law. So dh is equal to I into I'll directly substitute. You know, from this equation we are substituting. We are substituting to this equation. Okay, substitute to equation 1. So what will equation 1 become like? Equation 1 become like I into minus y into dx into az divided by 4 pi into x square plus y square the whole raised to 3 by 2. So now you know how 3 by 2 came. Same procedure. You know how 3 by 2 came. Same procedure, right? 3 by 2. First two, second one I have explained how 3 by 2 came. So same way, this same way the denominator will become 3 by 2. Only this coefficient, only this term is changing. Okay, you compare, realize, and understand the how the derivation flow is going. So you will get 3 by 2 here directly. Then x square plus y square is raised to 3 by 2. Now, if you check out the question, you can find out that in the question, each side is equal to 5 meter. So it is given each side is equal to 5 meter. That means this y can be taken as 5 meter, right? This y, the value of y can be taken as 5 meter because this distance is 5 because it is given 5 meter. That means y is equal to not 5, actually side is 5, right? So it will be half. Y will be 2.5 meter. The total distance is 5 meter. Yeah, so the half of that will be 2.5 meter. And it is also given the value of I is equal to 10 ampere. Okay, and now you substitute that to here. The same things you substitute here, then you will get it like 10 into. So in your question, if they were asking you find out the electric field like no, it was just like a derivation means up to here you should do and then you should integrate. So yeah, same procedure we'll do as a numerical problem. So 10 into y will be minus 2.5 dx into az divided by 4 pi into x square plus 2.5 the whole raised to 3 by 2. So you might have seen that we have taken the small length dx. So that small length dx need to be made to the complete length. For that, what should be the integration limit? dx ne nammal evada mudal evadam vare integrate cheyanam? 0 to 5 alla, minus 2.5 plus 2.5. 0 to 5 allallo. We need the complete length, right? Yes. So it should be from minus 2.5 to plus 2.5. So h is equal to integral x is equal to 2.5 to minus 2.5 because we are going from upper direction, lower direction to upper direction, right? So x-axis was in the lower side. So 2.5 to minus 2.5. So minus 2.5 dx into az. Yeah, this 2.5 I multiply with 10 and make it 25 because we have I into 10, right? So I will make it like 25 into dx into az divided by 4 pi into x square plus 2.5 the whole square, the whole raised to 3 by 2 is equal to, you know that you might have studied in mathematics, integral minus 2 pi to plus 2 pi, integral 2 pi to minus 2 pi is equal to 2 times integral 0 to 2 pi. Padichittundo?
Yes, sir.
Yeah, that's that same procedure we use here. 2 times integral x is equal to 2.5 to 0. Coming down. Yeah, 2.5 to 0 minus 25 by 4 into dx into az divided by x square plus 2.5 the whole raised to 3 by 2. Now this is actually a bit of integration concept. So lateral entry students and all, just study this as it is, because you may not be familiar with such this is actually higher type of integration. So in order to easily integrate this, what you should do is you should substitute x is equal to 2.5 tan theta. So this is actually a change of limits. What we are doing is change of limits. So that for that you might have seen you substitute like x is equal to t square. If you have a t square here, x, like such way you will substitute, and then you will bring that you will change the limits and you will do substitution. For in this particular question, so in this derivation, what we should do is we should bring x is equal to 2.5 tan theta. If it was in a normal derivation, it should be y square here, right? It should be y here. So that time you should take x is equal to y tan theta. So that way it should be. So dx is equal to 2.5 sec square theta d theta, which makes if x is equal. Now what we do, you know, in mathematics, what we do? Now what we do? We put what is the value of, we put the value of x is equal to 2.5 and find out what is theta, right? So x is equal to 2.5 means theta is equal to 45 degree, and similarly if x is equal to 0 means theta is equal to 0 degree. That is tan 0 is 0 only. Theta is equal to 0. Now we got the new limits. So new limits will be, so now we'll substitute the new limits. X is equal to minus 12.5 divided by pi integral theta is equal to 45 degree. So those who are very good in integration and all will find it very easily. So others, if you have any doubt, means ask me personally, like the integration and all other things, the mathematics things, I will explain to you. So now what we are doing is we just substitute x value, find out new limits, and this thing, so this dx will be replaced by 2.5 sec square d theta, and wherever we have x, we will replace that with 2.5 tan theta. So why we took 2.5 tan theta? Because we want to take 2.5 common from here, so that the derivation, so that the calculation will become easy. If it was x square plus 1 here, we could have taken only x is equal to tan theta. Because it is 2.5 here and we want to take 2.5 common, we took x is equal to 2.5 tan theta. Is it clear? Is it clear? Yeah. Okay. So 2.5 sec square into d theta into az divided by 2.5 square tan square theta plus 2.5 square the whole raised to 3 by 2. This is square here, okay? 2.5 raised to 3 by 2. So now it is all about mathematics. Nothing electromagnetic theory here. It's all mathematics here. So this one question I will solve. Maybe they will ask you the same question. Maybe I not know, because normally they ask for rectangle, or sometimes they ask for this is square also. Theta into az divided by 2.5 the whole cube 1 plus tan square theta. You see how we brought in 1 plus tan square theta. So now you might understood why we brought in 1 plus tan square theta, because 1 plus tan square theta is sec theta. So again we will substitute here is equal to 12.5, and this 2.5 also we will bring outside. I think it's 2.5 square only here. It's 2.5 square. 2.5 square, and so will be 2.5 square into pi integral theta is equal to 45 to 0 sec square theta into d theta by sec cube theta into az. So everything will get cut. So it will be, this minus sign is there. So minus 0.6366. So this will be very easy for you, because you can use calculator, right? So nothing to be worried about this. Just be careful when you take the identity values and when you put the limits and all. Just be careful. Other than that, there is no problem. So integral cos will be sine. So that sign, that minus sign we can remove. Sine theta 45 to 0. So what you are getting is, yeah, that sign is still there. Sine. So 0.6366 minus 1 by root 2. So what you will get? You will get 0.4501 AZ ampere per meter. So we are now talking about a complete square, right? So what we have done is only one side. We took a small length at one side and we integrated one side. So to find out the complete electric field intensity due to all the four sides, what we should do? We should multiply this with 4. So H due to complete square is equal to 4 into side AB, which is equal to 4 into 4501 ampere per meter, which is eventually 1.8, and the direction is still there, AZ ampere per meter. So this is the derivation. So I hope this is clear. So if you have any doubts, means you can ask me now.